Okay, so we are still on page 12. We're looking at number 13, and this is actually today's lesson. This is new. You did not have a video on this. This is complicated. You remember how I told you 9 weeks was the hardest 9 weeks of the year? This is complicated. With that being said, it is not the most complicated thing we're going to do this 9 weeks. So don't spaz on me, but hang in there. This is something that takes lots of practice. So there are going to be days next week where I just have you practicing something I've already taught. It's not going to be new information. It's just going to be practice, 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 practice. I may throw in one that has a little twist, but the problem on number 13 says the square root of 2/10. And actually, I apologize. If you had an extra sheet of paper, don't get rid of it. But I meant to tell you this. Turn to page 14 in your packet. This is where you're going to put notes on what this new lesson is, which is rationalizing the denominator. And I know I told you number 13, we're going to come back to that one, so we won't forget it, but I'm actually starting with a different problem first. Simplify the square root of 19 over the square root of 18. Now, while you are doing that, I'm going to turn back to something you don't have to turn here. But when we did notes on Friday in our Google Meet, we looked at page 4 in your packet and we filled these in. Well, the last two I told you we're going to ignore from now. We'll deal with those later next week. Well, I'm going to talk about them now. Number 2 on page 4, and you don't have to turn there because I'm going to tell you what it is. It says no radicals contain fractions. We wrote that down on Friday. No radicals appear in the denominator. So what the second bullet means is you can't have a fraction under the square root in your final answer. The second one means if you've got a square root in the fraction, it cannot be in the bottom. Can't be in the denominator. You can have a square root in the top, but you can't have a square root in the bottom. So what we're going to learn today is how do I get rid of the ones in the bottom? And that's in order to be in simplest form. So when I look at this one, there's a square root in the bottom, and we can't have that. So over here on the right-hand side, there's a rule I want you to write down, and that rule says, if I take the square root of two numbers that are being divided, I can break that into the square root of the number on top divided by the square root of the number on the bottom. We wrote a very similar rule for multiplication. The rule for multiplication said if two numbers are being multiplied under the square root, you can break them apart into two square roots being multiplied together. So the same thing works for division. So I'm actually going to show you 2 ways to do this example that we're doing, not because I want you to write more, because sometimes my brain thinks one way and sometimes my brain thinks the other way. So I want to show you both ways, because according on the problem, one may be a little faster than the other. On some problems, like the one we're getting ready to do, there's a lot of steps no matter which way you use. Okay? So the first thing I'm going to show you is what if we use this rule over here to the side and we said, let's put all of those under one big square root and then go from there. Now I'm going to tell you why this cannot be our answer, because that second bullet said you can't have a fraction under the square root for it to be your answer, but you can have a fraction under the square root to get to your answer. So what I would then do is I said, hey, 9 and 18 have something in common. They're both divisible by 9, right? So let's simplify this fraction. 9/18 is actually 1/2. So by putting them under one square root together, I could simplify the fraction. Now I need to break them apart using that same rule. And what's the square root of 1? 1. But the square root of 2 is not a perfect square. So we can't break it down. It's a prime number. But that rule we just looked back on page 4 said you can't have a square root in the denominator. So this is where we got to figure out how do I get rid of it. And the way you get rid of it, if you've got a square root in the denominator, you multiply the denominator by that same square root. Because the square root of 2 times the square root of 2 is the square root of 4. And what's the square root of 4? 2. So on this bottom, I'm going to get 2. The square root of 2 times the square root of 2 is 2. But there's a rule in math that says if you want things to still be equivalent, whatever you do to the bottom of a fraction, you have to do to the top. So if I multiply that bottom by the square root of 2, I also have to multiply the top by the square root of 2. And let me tell you why. Anything over itself is just 1. If we multiply something by 1, isn't it still the same number? So by multiplying by the square root of 2 on top and bottom, we've just multiplied by 1. So it's still the same. So 1 times the square root of 2 is the square root of 2. Are there any square roots in the denominator? So we're done. So I see some of you give me a confused face right here, so I'm going back up. Square root of 2 times the square root of 2. 2 times 2 is 4, and the square root of 4 is 2. So that's how we get 2 right here. Because when you multiply those two together, you get 4 under the square root, and the square root of 4 is 2. So when you multiply a square root of a number times the square root of that same number, you're just going to get the number that's under the square root. Now I told you I'd do that same one a different way. So I'm going to show you the different way with a different color pen so you don't get confused. Same problem. We're going to get the same answer, just a different way. So let's say you're starting with that same problem and you recognize right off the bat, hey, the square root of 9, that's a perfect square. What's the square root of 9? 3. So you say, okay, I'm going to change that top to 3 and leave that bottom, the square root of 18. Why can that not be my answer? For two reasons, and I heard them both, I think. Square root of 18 can be simplified, meaning we can break it down using the singles mingle, and we can't have a square root in the denominator. So we got to fix both problems. So here we could take two different routes. So I actually could write this 3 methods here, but I'm not going to make you write 3. So I'm going to tell you the 2 methods, and we'll just roll with them. The first method is we could go ahead and break the 18 down using the singles mingles method and then rationalize the denominator. Or we can rationalize the denominator first and break it down afterwards. Let's rationalize the denominator first. If I rationalize the denominator first, I'd multiply the bottom by the square root of 18, and whatever I do to the bottom, I must do to the top. So on the top, that would give me 3 square roots of 18 over 18. Because the square root of 18 times the square root of 18 is just 18. Then I see 3 and 18 have something in common. What do they have in common? 3. So I'll divide them both by 3. 3 divided by 3 is 1, and 18 divided by 3 is 6. So 3/18 becomes 1/6. And if you want to put the 1 out front because that helps you, you can put the 1 out front. But now we go to the second reason that we said this one's not finished, because 18 will break down. It has a perfect square that goes into it. If you recognize the perfect square that goes into it, you can use that method, or if you like singles mingle, 18 with a factor tree. So I have a pair of 3s. The 3 has to go out front. The 2 stays under there. Why is that not my answer? Because 3/6 can be reduced or simplified to 1/2, right? 3 over 6 is the same thing as 1/2. So that would be 1 over, isn't that the same answer we got up top? I know they look to be about the same number of steps, but we did have to draw some down here. I think for the first one, my brain would have worked better by putting the 9 and the 18 together and simplifying from there. There are other times that what we did on the second one would make more sense to me. If the square root of 9 had been in the bottom and the 18 in the top, this would have been a much easier problem. So we're going to do another example like this, but I am going to pause here. I'm going to stop the video to start another one and let you guys take that stretch break we talked about. Okay? So go ahead and you stretch and I'll stop the video.